Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 5-9 Extra Practice Number 2 solutions on quadratic trigonometric equations. For this problem, we're trying to solve this trig equation for angles between 0 and 360. Since I've got a quadratic basically, and I've got everything on one side of the equation, I'm just going to start by trying to do a little factoring. This is kind of like having 2x squared minus radical x. 2 radical x. So we're just going to factor out one of these cosines from everything. That will leave me with a 2 cosine theta minus radical 2 inside the parentheses. And now I can set each of these things equal to 0 and solve. So we have the case where cosine of theta could equal 0. And if we set this parentheses equal to 0 and solve, add radical 2, divide by 2, we have cosine of theta also could equal radical 2 over 2. So if we look over here with the case where cosine equals 0, there's only 2 places on the unit circle where cosine is going to have a value of 0. This is the x value of your angle. That's going to be 0 on the y-axis. So at the top and the bottom of the unit circle at 90 degrees and 270 degrees. Over here, we note first that cosine is positive. So that's important because the x value of the angle being positive means that the angles we're looking for are going to be on the right side of the y-axis. So we're going to be looking in quadrants 1 and 4. So let's do inverse cosine to figure out kind of a foot in the door what our initial angle is going to be. Now you might remember that the cosine of 45 degrees is root 2 over 2. So the inverse cosine of root 2 over 2 is 45 degrees. But you could find that on the calculator. That happens to be a reference angle, so it's going to be helpful for finding angles in these other quadrants here. Now for quadrant 1, 45 degrees is in quadrant 1, so that's actually already one of our answers. To find the quadrant 4 answer, we just need to start at 360 and go down from the x-axis 45 degrees, so 360 minus 45, giving us 315 degrees for our other angle. To solve this trig equation, we first want to isolate the trig function, cosecant of theta. We can do this by adding this 3 cosecant squared of theta over to the left side. That'll get those together. So that's going to give us just 1 cosecant squared of theta on the left side, equaling 2. Now at this point, since we have just something squared and a constant, we can square root both sides of the equation. So we can say that cosecant of theta is going to equal plus or minus the square root of 2. So this is going to give us 2 different equations to solve. Now in both cases we're going to have to convert this to sine, taking the reciprocal of both sides of the equation. If I turn radical 2 upside down and make it 1 over root 2, that actually simplifies to root 2 over 2. So we can write sine of theta equals positive root 2 over 2, and sine of theta equals negative root 2 over 2. So now to solve this equation on the left here, we note first that sine is a positive number. Since this is the y value of the angle, that means our angles have to be above the x-axis in quadrants 1 and 2. Inverse sine of root 2 over 2, that's going to be 45 because sine of 45 is root 2 over 2. And that happens to be a reference angle, so that's going to help us get all the angles we need here. So quadrant 1 angle, we need that. That's going to be 45 degrees. We actually already had that one from the beginning. And for quadrant 2, we're going to have to start at the 180 line and go backwards 45 degrees above the x-axis into quadrant 2. So 180 minus 45 is going to give us 135 degrees. Over here, we're going to do inverse sine, or actually we have to figure out what quadrants we're in over here. So we note that sine over here is negative. So we're below the x-axis in quadrants 3 and 4. That's where the negative y values are. Sine inverse of negative root 2 over 2 is going to be negative 45. Still have a reference angle of 45 degrees. You're still 45 from the x-axis, just in a different direction. So for quadrant 3, we have to do 180 plus the reference angle. That gives us 225 degrees. For quadrant 4, we're starting at 360. And then to go down from the x-axis 45, we have to go backwards 45 degrees. So 360 minus 45 is going to give us 315 degrees. To solve this trig equation, I notice that I've got some squared trig functions. So I'm going to treat this like a quadratic and try to get everything over to the left side here. And the reason I don't put constants on one side, squareds on the other, is I notice I've got this single power cotan. So I'm going to try to zero this out and factor. So adding 4 cotan squared theta to the left side, that gives me 1 cotan squared theta. I still have a 2 cotan theta and a 1 over there on the left. And now if I factor this, I just need things that multiply to 1 and add up to 2. So this would be cotan of theta just plus 1, and we need 2 of those. So that would be squared. So this is actually pretty good news. We actually really only have one factor to deal with. Setting this equal to 0 and solving, I see that cotan of theta must have a value of -1. Well, I can't really do much with cotan, so I'm going to take the reciprocal of both sides and turn that into tangent. So I can say tan of theta equals -1. And at this point, solving this equation here, I notice that tan is negative, which means that my slope of my angle is negative. So that means I'm in the quadrants with negative slopes, quadrants 2 and 4. So let me do inverse tan of -1 to get some kind of angle to start with here. Now I happen to know this is going to be -45 degrees because I know tan of 45 is +1. So same deal with -45 if you take the tangent. So this is -45 degrees. The reference angle out of that, which is what I actually need to get these answers, is going to be 45 degrees. So to get my quadrant 2 answer, I'm just going 45 degrees up from the x-axis, so that's going to be 180 minus 45 to give me that angle, going backwards 45 degrees basically. That's 135 degrees. And then for quadrant 4, we're starting at 360 and going down from the x-axis 45 degrees into quadrant 4. So that's going to be 360 minus 45, which is 315 degrees. Now, this problem actually wanted us to solve for this in radians, so it's okay to do the whole thing in degrees, but you do need to convert to radians at the end at least. So to do that, 135 times pi over 180, this is going to be, let's see here, 3 pi over 4, and this one down here is going to be 7 pi over 4. To solve this trig equation, since I've got squared trig functions and non-squared trig functions all kind of mixed together, let me see if I can get everything over to one side and factor this thing, kind of like a regular quadratic. So I'm going to subtract sine squared from both sides. I can rewrite the left side in order as 2 sine squared of theta minus sine of theta minus 1. All of that equals 0. And now I'm going to try to factor this thing. I know I need a 2 sine of theta and a sine of theta. And I also know I need a positive and a -1. I probably want to make sure I'm multiplying the 2 sine of theta by a -1, though, so that I end up with a negative result when I add things together. So I'm going to do 2 sine of theta plus 1 and sine of theta minus 1. So this will give us a -2 sine of theta plus a sine of theta to give us that negative sine of theta in the middle. All right, so this should equal 0. And now we'll just set each of these factors equal to 0 and solve this. So if 2 sine of theta plus 1 equals 0, subtract 1, divide by 2, we see that sine of theta is going to be -1/2. And if sine of theta minus 1 equals 0, then we know sine of theta has a value of +1. Let's go back over to this other branch now. I notice here that sine is negative. Y value of the angle is negative. That means I'm below the x-axis in quadrants 3 and 4. So let me do sine inverse of -1/2, which I happen to know is going to be -30 degrees. We need a reference angle, though, in order to get the quadrant 3 and 4 angles. 30 degrees down from the x-axis means our reference angle is actually 30 degrees. So to get quadrant 3, we just need to go 30 degrees forward from the 180 line. So that's going to be 180 plus 30 degrees, and that'll be 210 degrees. We'll worry about converting to radians a little bit later. Next, quadrant 4, we're going backwards 30 degrees from 360. That'll bring us down from the x-axis into quadrant 4. So for that one, we need to do 360 minus 30, which gives us 330 degrees. And now let's take care of this branch over here. There's actually only one place that sine equals 1 on the unit circle. The only place with a y value of 1 is at the top of the unit circle at 90 degrees. So let's go back and convert all of these into radians now. 210, that's going to be 7 pi over 6. 330 is 11 pi over 6, and then 90, that's just pi over 2. For this problem, we just need to figure out all the angles between 0 and 2 pi that solve this trig equation. So I'm going to go ahead and just square root both sides to get cotan by itself. Now you got to be careful when you do this because you have a plus and a minus root out of this. So we have cotan equals plus or minus 1, so +1 negative 1. And now I'm going to go back and deal with each of these branches individually. So easy to forget that negative root, though. So back to the positive root. We'll do that one first. I can't really do much with cotan, but I'm going to take the reciprocal of this whole equation to get tan equals 1 over 1, which is just 1, because tan I know what to do. So I notice that tan here is positive. That means that for this branch anyway, my angles have a positive slope, which means they are in quadrants 1 or 3. So let me get a reference angle and see if I can figure out what they actually are. Inverse tan of 1, I know off the top of my head, is 45 degrees, which happens to be a reference angle. It's also the quadrant 1 angle, so that's nice to get that right off the bat. And then for quadrant 3, we need to do 180 plus 45 to bring us down 45 from the x-axis into quadrant 3. That's 225 degrees. We'll go back later and figure out the radians. Let's just get degrees answers for now. Going over to my other branch, I can write tan of theta equals the reciprocal of negative 1, which is also negative 1. Inverse tan, and that's actually a negative, so that means our angle is going to have a negative slope, which means quadrants 2 and 4. So inverse tan of negative 1, that's negative 45 degrees. Reference angle on that is actually also 45 degrees. So to get quadrant 2, we're going up 45 degrees from the x-axis. So that's 180 minus 45. You're going backwards 45 degrees to get 135 degrees. For quadrant 4, we have to start at 360 and go backwards 45 degrees to go down from the x-axis. So 360 minus 45 gives us 315 degrees. And now going back through and converting all of these to radians, we've got 45 turning into pi over 4. 225 is 5 pi over 4. 135 is 3 pi over 4. And 315 will be 7 pi over 4.